name is John Schultz, and I'm with the Compass Technology Group. And today I'm going to show you our shielding effectiveness method, which is a method that uses our focus beam system. Our focus beam includes a horn and a lens, and then another lens and horn on the other side. And we normally use this to measure transmission or reflection through materials. For shielding effectiveness, we're worried about conductive materials, and in conductive materials, not much energy goes through them. And because sample sizes tend to be finite, what happens in a shielding effectiveness measurement is that the energy will go around the sample rather than through it, and that gives us a false reading. So obviously, in our case, we built a large metal wall, and we have this clamping system for securing our sample so that energy does not go around it, and we measure only energy going through that sample. That improves our signal to noise. So as you can see here, we're mounting our sample. In this case, we're measuring a piece of conventional window screen. We're mounting it by screwing it into the frame so that we make good electrical contact. We do this because while our focus beam creates a nice narrow Gaussian taper on the middle of the sample, the little bit of energy that leaks around needs to be blocked, and we use the screws to make sure that nothing leaks through the cracks. Now, before we measured our sample, we originally calibrated. Calibration included a clear sight, which was measuring nothing, and then secondly, we measured a metal plate, and that metal plate is 100% reflection or 0% transmission. And then we used those two standards to compare to our data. We also previously measured a metal plate a second time, and we have that data up here now, and you can see these blue and green lines show the transmission, S21 or S12, in the two different directions, and you can see that the levels are at the minus 110 or greater dB level. That kind of tells us our noise floor and tells us how good we can measure. Now we're going to go ahead and measure our screen. And we're scanning from 2 to 20 gigahertz, and we're taking 7,201 points. And we do that so that we can use time-domain gating, and that allows us to make sure we have lots of unambiguous range so we don't catch any reflections from the room. So you can see in the result, we now have our blue and green line here, nowhere near our noise floor, significantly higher. Starts out around minus 32 dB for the transmission coefficient at 2 gigahertz, and then goes as high as about 14 or 15 dB at the upper end of the frequency range. So the screen allows a lot more energy to go through than a metal plate. Thank you for your time. This was an illustration of how we use a focus beam to measure shielding effectiveness.